In this video, we're going to determine the number of valence electrons in the following ground state elements. So let's do the following examples. Let's do beryllium, Be, let's do silicon, Si, and let's do chromium, Cr. So what we're going to use is our periodic table. Now you can see here that we have our beryllium right here. We have our silicon over here to our right next to aluminum. And then we have our chromium, which should be sitting right here in the middle. There it is, number 24. So we have those three elements that we're going to work with. Now it's a little bit difficult to see from here, but let me redraw this to then give you a better idea of what we're looking at. So our S block looks something like this. Our D block looks something like this. And then our P block looks something like this. This is just a simplified way to look at our periodic table. Now we have different blocks. As I was saying, we have our S block, which is over here on our left. We have our D block, which is here in the middle. And we have our P block, which is here on the right. We also have the F block on the bottom, but we rarely use that, so let's just focus on S, D, and P. Now we can use these to really simplify and find our number of valence electrons very quickly. So you can see in our S block we have 2 columns. In our D block we have 10, so we'll just say 1 all the way through 10. And through our P we have 6. Again, 1 through 6, 2, 3, 4, 5, and then 6. From their position in our rows and our columns, so we have our rows all the way from 1, so 1, 2, 3, 4, 5, 6, 7, all the way through 7. We can use all this information to make our lives very simple. So our energy level, or these numbers here on the left, our rows, will help us to figure out which energy level our element is in, so whether that's 1 through 7. Our vertical numbers, our columns, these ones here at the top, are going to tell us our final electron position. So anything in this first column are going to be S1, any in this second column are going to be S2, D1 all the way through D10 typically, and then P1 all the way through P6 typically. So it simplifies us to trying to find those valence electrons. So let's follow our examples. So for beryllium, we found that over here. So we're going to find first its energy level. So it's an energy level 2. So we know it should end in a 2. It's in our S block. It's also in our second column. So it should end with something like 2s2. We can write out the full electron configuration, which would be 1s2, 2s2. And from this, we can see that our valence electrons is our highest energy level. Furthest one out, that's going to be 2s2. So we have 2 valence electrons. Now let's try silicon. So silicon we can see is in our third energy level. It's in our P block, and it is the second chemical over. So it's going to be end in 3p2. So as you write out its full figuration, it's going to be 1s2, 2s2, 2p6, 3s2, 3p2. So again, looking at our highest energy level, we have our 3s2 and our 3p2. So this will have 4 valence electrons. Now let's look at chromium. This one's going to be a little bit different because it's in the D block. And the D block doesn't follow exactly the same rules as the S and the P block. So first off, we can see that it's in energy row number 4. Here's the first part where it differs from the S and the P block. Even though it's in energy level 4, it's actually going to be a 3D energy level, simply because our D elements are supposed to be shifted up 1 to more match these rules that we're using, but the periodic table is designed this way to make it more chemically compatible. So we just have to keep that in mind, that for our D block, take whatever your energy level is, subtract 1, and that will be the correct energy level to place our valence electrons in. So it's going to be 3D, and then it's 1, 2, 3, 4. So it should end in a 3d4. So now let's write out its full configuration. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and now it is 3d4. So again, a little bit different than the other ones. We're going to include our 4s, and our 3d6 to determine the number of valence electrons. So this is going to have 6 valence electrons. So transition metals are always a bit tricky. So we're going to use, whenever we run into those, so for our transition metals, which are going to be our D block elements, we're going to use the highest N, which is our, in this case it was the 4s. We'll then also use our P, or our S, P and D block to then determine our valence electrons. In other words, kind of using our example here, let me rewrite that. Just the part that matters, we'll do our 3s2, 3p6, 4s2, 3d4. So you want to find the first instance of our highest energy level, which is a 4. That's going to become our starting point. So we'll kind of chop everything else off to the left, and we'll only keep everything to the right. So even though this 3D is a lower energy level, the 3 is less than 4, it's going to be higher in terms of potential energy compared to the 4s. So we're going to include it in our valence electrons. So everything to the left, we're going to toss, and everything to the right, we're going to keep. And that is why we have 6 valence electrons for chromium.